Hello everyone, welcome to part 3 of this video. So we're going to go ahead and talk about logarithmic and exponential functions. So I want you guys to recall what is exponential growth and exponential decay. So let me go ahead and start by drawing two little axes here, just to go ahead and stamp this point right here. So we have exponential growth and exponential decay. Exponential growth happens when we have the base A, the variable, the number A is bigger than 1, okay? And decay happens when we have the number A that is less than 1 but bigger than 0. So we have the following. We have these graphs right here. When it is growth, it starts very, very close to the x-axis, and then it increases exponentially, right? Really, really fast. And then we have decay, that it grows from very large amounts, very big amounts of my y, and then decreases very, very close to my horizontal line, my x-axis. X-axis. Okay, so we have something like so. Now, what I want you guys to know is like, hey, we have the following. They want us to find out, hey, which one of these is representing exponential decay? Meaning, we want something that is decreasing, right? So my value of A, which is always the number that has the exponent, this x, it has to meet this restriction between 0 and 1. So right here, this 1/3. Now keep in mind, they might want to trick you with this 1/4, but keep in mind, we only want the one that has the exponent of x. So this 3 right here, this one's pretty simple. This the e, and then this one looks a little complicated. This 1/2 times the 1/5, but keep in mind this, so the one with the exponent, so this right here. So which one of these would actually be doing, or which actually be happening exponential decay? Okay, so hopefully you notice that A is the only option because 1/3 is 0.33, and that is less than 1 but bigger than 0. Everything else, like this 3, right? This 3 right here is bigger than 1, so that's not an option. E might have confused you a little, but remember E is about 2.71 continuously, so that's bigger than 1. And this one's a little confusing, but 5/4 is actually bigger than 1 because 1 is the same thing as saying 4 divided by 4. So 5/4 would not be it. The only one that is less than 1 would actually be A. Okay. Let's continue with the next part, and let's talk about domain of a log function, an ln, right? A log. Okay, so we have the logarithmic function is actually the inverse of an exponential. So we just saw how the exponential was. It was something that was like the last slide. So if we go and reflect it over the line y equals x, we have something like this. Okay, this right here will eventually get really close to my y-axis. This is log of x. Okay, now I want you to think about, since these two, the y-axis, it's very close to our log, there's actually a vertical asymptote at x equals 0, or my y-axis. Okay, now what does that mean for the domain? Can we have negatives in this log function if we know there's a vertical asymptote at y equals x? Unfortunately not, right? This domain of the basic parent function log of x is all the positive numbers, so parentheses 0 to infinity, meaning whatever is inside here, whatever's inside the parentheses must be greater than 0. Okay, so let's go ahead and find the domain of what is asked of us. So we have log base 5 for x minus 3. Okay, so we're saying that the domain is all the numbers bigger than 0. So all of these numbers that are bigger than 0. So we're going to go ahead and say 4x minus 3 is greater than 0. So go ahead and pause the video and find me that domain. Okay, so hopefully you were able to solve for x. So plus 3, 4x is greater than 3 divided by 4. So we have x is greater than, greater than 3/4. So if we were to have a number line, this is 3/4, and x is greater than all the numbers, x is greater than 3/4, our domain must be which of these right here. Which of these will be our domain? Hopefully you saw that all the numbers to the right of 3/4, right? All the way to right is infinity. So our domain has to be from 3/4 all the way to infinity. So 3/4 to infinity should be our solution. Okay, so that means that we can pick any number that we want as long as it's in that interval and we can evaluate it. Okay. All right, next one that I want you guys to try is expanding and compressing log functions. So keep in mind, the two things that I want you guys to know is that whenever you have a log with the same base, if they are adding, so log base b plus log base y, that means addition of same logs is multiplication of the inside, so x times y, okay? The next thing that I want you to know is that if there is a log with the same base, let's go with the x minus log of the same base, and they're being subtracted, that means division of these. Okay, so these are the two notes that I want you guys to have. And now we're going to go ahead and apply this so we can separate all of this. Okay, so go ahead and write that down, and we're going to go ahead and begin. Okay. Oh, something I did forget. Keep in mind, if you have an exponent, so let's say c log of b of x, that c becomes the exponent, and vice versa. If you have an exponent on c, it becomes the leading coefficient. Okay, so let's go ahead and begin by looking at this. We have log, we have square root of y divided by x squared z to the third. Okay, so what I'm seeing here is that I need to have three different parentheses because I have three different variables. So I'm going to go ahead and write log base 4 three different times, right? Square root of y, and I feel like I'm going to run out of space. Keep in mind the x is in the denominator. That, according to this, it is division, right? If there's a fraction, so it's going to be log base 4, and I'm going to keep my x. Keep in mind the z is also there, so it's going to be minus, again, log base 4 z to the third. Okay, now keep in mind we have exponents, that log base 4 right here. This one's good, but however, this log base 4 y to the 1/2 actually needs some work. So let's go ahead and fix those right here. Keep in mind the square root of a value is the same as the exponent 1/2. So this is actually log, so sorry about that.
All right, this message is for all teachers who have any students remaining. You may escort them.
Sorry about that, guys. I'm still at school. So log base 4 y to the 1/2 exponent minus, let me just write this again, log base 4 x. What will be log base 4 z to the third? How will that be written? Hopefully you said that you get this exponent, you bring it to the front, so it's going to be 3 log base 4 z. So this 1/2 would also go right here. And this is very messy. This is, our final answer should be 1/2, right? Because the 1/2 went to the front. Log base 4 y minus log base 4. I should really close my g's. X minus 3 log base 4 z. Okay, that right there will be our solution, which appears to be either C or D, which is D. Sorry about that. So D. Alrighty. Okay, how about compressing? So given what we know, go ahead and try to compress it. Which one of these do you think it will be? Okay, So hopefully you saw that, hey, if I have a 3, that becomes my exponent. So now I have log 2a to the third. This right here minus is going to go ahead and tell me some sort of division, right? So I'm going to leave it like this for a little bit until I compress all the exponents first. So this 1/2, so it's going to be plus log c to the 1/2. And we agreed that, hey, if you have a square root, that is the same thing as saying exponent to the 1/2. So we have log squared, I'm sorry, log base 2a to the cubed minus log base 2b plus the log square root of c. Okay, now we can go ahead and compress everything one last time. So we have this final answer of log base 2. I'm going to write these in big parentheses. I got a cubed, right? A cubed, and then subtraction of b means division of b. And then keep in mind, I'm adding it, so it's going to be multiplied by square root of c. So my solution should be, it appears to be, let's see, this one, I got a cubed c or b. It appears to be this one. Just to be sure, let's look at the rest of them. Keep in mind, you should not have additional logs, so that one's out. And then keep in mind, for this one, C, B is dividing everything, and that's not possible. B should only be dividing its variables, okay? And then this one, the error that they made is that they put the exponent 3 on the C. So rookie mistake right there. So A should be our solution. I believe I have one more example. Yep, one more example. So let's go ahead and give this one a try. Using what you know, guys, we're going to go ahead and try to solve for this one, okay? So we have all of this right here. We have 5 is equal to log 2, 2 plus log 2, I'm sorry, 2 times log base 2x minus 3. So first thing I want you to do is go ahead and compress this. So we got that 2. Let's go ahead and put it to the top. So we have log base 2, 2 times log base 2 x minus 3 squared is equal to 5. Okay, by doing a little bit more compressing, we get that 5 is equal to log base 2, 2 x minus 3 squared. Now, something hopefully you remember is the snail method. So keep in mind the snail method said that you get a base. So let's say base b, and you can go ahead and make that base of whatever it's equal to. So x is equal to b raised to the a. Sorry about that, a. Okay, so that's what we're going to go ahead and do. So 2 raised to the 5th, right, is going to be equal to 2x minus 3 squared. Okay, so let's go ahead and simplify that. 2 to the 5th is actually 32. And then we have x minus 3 times x minus 3. So a little bit of FOIL, a little bit of distribution should help us right here, giving us x times x is x squared, and x times minus 3 is minus 3x. And you go ahead and repeat the procedure, so 3 minus 3x, and negative 3 times negative 3 gives me a negative 9. Okay, don't forget that that's all of that's being multiplied by 2, but we can go ahead and simplify by dividing by 2. So getting rid of this by division of 2, division of 2 gives us 16 is equal to x squared minus 3x minus 3x minus 9. Okay, so let's go ahead and combine some of these factors, but I believe you guys can take it from here. So go ahead and simplify and find out what are the values of x. Okay, sorry guys, it appears I made a mistake when I multiplied negative 3. Negative 3 times negative 3 actually gives me a positive 9. So that's what threw me off. Okay, so let me go ahead and erase a little bit right over here. This right here should actually be this written a little bit prettier. Gives me 16 is equal to x squared minus 6x plus 9. There you go. So we can go ahead and put everything on the same side. So we got x squared minus 6x plus 9 minus 16. And we can simplify this by saying 6x 9 minus 16 gives me a negative 7. So from here, we can actually factor this. So what would be the factor of x squared minus 6x minus 7? Hopefully you said that x. We have an x minus 7, right? Minus 7 and a positive 1 to go ahead and give us this factor. And we set each one equal to 0, we get x is equal to 7 and x is equal to negative 1, right? If we set each one of these factors equal to 0 and solve, we can see that x is 7 and x is negative 1. However, as much as I want to go ahead and tell you, hey, both of these are answers, only one of them is your actual answer. Keep in mind, we just talked about the domain of a log function. The domain is all the numbers, right? All the numbers bigger than 0. So all the numbers, so where x is greater than 0. So can we have a negative right here? No negatives. So our only answer is 7D. All right, 7. Keep in mind, this is a solution, but it's an extraneous solution. Okay. Alrighty, guys, hopefully that helped. This covers our exponential and logarithmic properties and functions. But if you do have more questions, reach out to me and we can go ahead and work something out. Awesome. And a friendly reminder, my office hours are at 2:30, so swing by if you have more questions. See ya. Bye-bye.